Okay guys, so today we are going to be finishing up 10-1, so you should be getting a second pack here. It should start off with significant tests for P1 minus P2, so we're going to be working through that here today. Why don't you take this and staple it onto your first half, your 10-1, so you'll have like a nice 3-page, beautiful copy. Last page will be on all homework, and you can use the blank side and the back page too as well. We'll do that for 10-1. So today we're talking about significance tests, and I just want to review quick. This is going to be a quick lesson, so you're going to have to pay attention real good. Let's go quickly over what a one-stat hypothesis test was, okay? So this is what we did in Chapter 9. For instance, let's say the mean, let's see, the proportion. So we'll say proportion of, say, students who make obscene comments on live streaming idea sites is maybe, let's say, 20% of high schoolers. That's the world. Okay. Now, let's say we took a random sample. We took a random sample of, let's say, 50 outstanding Craig students and their obscenities on live streaming websites. The percentage of those were, let's say that they were more on the 30% range. Okay? Alright, so let's see. Is there a difference? Does it seem like Craig might have more students who are talking dirty on live streams? Okay, so we would normally set up a hypothesis test. We'd say, hey, H-O. Listen, it should be, P should be 0.2, right? We want to test out, I wonder if Craig has actually got a larger percentage of this event happening. Alright, so that's going to be our hypothesis test. Then we do all of our tests and all that kind of jazz. I'm not going to go through normal and random and all that kind of stuff. But I would set up a z-score. And I would say, okay, what did I get? Remember, what did I get? My p-value is 0.3. Sorry, not p-value, but my statistic is 0.3 minus what I should have got all over my standard deviation. If you remember standard deviation for percentages, it's your square root of what you should have got times its inverse all over the number of people we sampled, which was 50. Okay. And then we would go on to find our p-value and see what the percentage is likely. Okay, that's old way. New way. We're going to be comparing between two different statistics. Alright, and yes, my notes are very old school. I'm getting pretty lazy in my old age. This is exactly what you got, so if you can't read it carefully, just look down at your own piece of paper. So, when comparing between two proportions, okay, when writing our hypothesis test, we always assume there should be no difference. Okay, there's really no difference, hopefully, right? If school A did it this way, school B did it this way, we assume there should be no difference. Now, is there a difference? So how would we write a hypothesis test? We would say, hey, listen, probability of 1 minus the probability of a second really should be what? If I take my probability of my first, probability of my second, there should be no difference, so really the difference should be 0. There is no difference. Okay, now, this can be written another way and you can see it a different way. It's kind of up to you how you want to write it, how gels best in your mind. But would you not agree that this is the same thing as P1 is the same as P2? Okay, meaning they are equal. There is no difference, they're the same. And if you don't agree, you can add P2 to both sides, right? And doesn't that give me P1 equals P2. Okay, should, hopefully. Okay, now, so then our alternate hypothesis, well, it's going to be likewise, all right? So I'm going to have P1 minus P2, now depending on whether or not, let's say we're trying to see if something's less than, if the difference is smaller, well, then that would be a less than sign, right? And then P1 minus, is less than P2, okay? And yes, it's going to be the same sign, okay? Same sign. You're not going to have to flip-flop it around. So I know sometimes it gets a little trippy when you're reading that stuff through. But that would be in case it was less than. Obviously, we still have the greater than sign. That's a possibility. Or the not equal to, which would be a two-tailed test. So same stuff applies. All right. We still must check all the properties. So we still need to check whether it's random, whether it's a normal curve, and whether it's independent, or the 10% rule, right? Okay, so there's still going to be those three things we need to check. To make sure we use a what score? What score do we use, guys, when we do stuff with P? Well, it's a z-score, right? T-scores are only when we are using a sample standard deviation. Okay, so moving on. Couple things here. And you'll find this in the book. Notice down here the different ways that you can write out your alternate hypotheses, okay? Or you could rewrite it, in this style as well. All right. I would star this because this is kind of an important concept down here, because there's one thing that's different than the confidence intervals that we were using yesterday or a week ago. You'll notice we have PC down here now. Notice how PC is on both sides? Huh. You remember when we do confidence intervals, we do P1, P1, and then we do P2, P2. Okay, but now why are we doing PC when we're doing a z-score here for this? Alright, well, let me bring you back, and the reason why I did that first problem here is, remember when we use a z-score just for a one test, okay, one stat test, what percentages do we use down here? Do we use what we got? Do we use 0.3 down here? No. We're using the percentage that it should be. Right? We're using what percentage it should be down here. So we're putting 0.2 and 0.8. Right? Because we actually knew what the national average was of students who talk dirty on live streams. 20%. On this, though, do we have a true mean? Or a true proportion? I don't see anything. The only things that we would have possibly is 0. And anytime I put 0 in a denominator, that just doesn't look ever pretty. Okay, you're going to get undefined every stinking time. So what is PC? Okay, what is PC? Well, it's our best estimated guess, basically, of what it should be. What should be the true proportion of these two events happening. So what we do is we take our proportion of 1. So let's see. We take our P1, okay, or our amount of it happening, and we add it to our P2, okay? That is going to equal basically our PC. It's basically a combination. So it's the two put together. It's basically going to be like the mean of the two events happening. Okay, it's the best guess that we can have. So that's why we're going to put it there. Be careful when we're doing significant tests, because we're going to have to do PC in this situation. So let's knock it out. Let's get our hands dirty. All right, so here we're talking about high levels of cholesterol, and they're trying to do a situation where they're giving them a drug called gemfibrozil. I don't know if that's how you pronounce it, and then they're also going to do a placebo of 230 men doing a placebo. All right, during the next 5 years, everything's simple random. 56 men who took that, and 84 men who took a placebo had heart attacks. So, is there apparent benefit to this drug called gemfibrozil? Does it seem to improve heart attacks? Does it seem to lessen heart attacks, actually? That's probably what we're more interested in. So if you find your probability of the first event, we'll say with gemfibrozil, so P1 is going to be, well, I have 2,051 who took it, and 56 men had heart attacks. So how many had heart attacks as a percentage? I got a percentage of 0.0273. And my P1, or P2, sorry. This would be the people who took placebos. So they thought they were taking something that was going to improve their heart condition, but really not. Let's see, 84 of those poor, hopeless people, which equals 0.0414. Alright, and the last big important one, now remember we got to find PC, the combination of them both. Well, what would it be if I added 56 and 84 together? I got to add 56 and 84 together. So 56 plus 84, so how many people had total heart attacks, plus the total, so 2,051 plus 2,030 even. Okay, so if I add those together, I find basically what's the percentage combination. Well, that would be somewhere between the two at 0.0343. That is our best guess estimate at where it should be, right in the middle, right? And there would be well, it'll be the average. Okay. So let's knock it out. HO. P1 minus P2. What are we thinking? There's probably, we're going to say there's no difference at all. Alright? We're going to test, though. We're going to see if these drugs actually did help. So we're going to see if P1 minus P2 actually lowered heart attack risk. Okay? Did P1 actually have a smaller amount? So, I'm going to do my Z-score. By the way, I am going to skip over for time's sake because my wife is due any minute now. I'm going to skip over your test, but yes, you still should do random, normal, and independent tests. Okay, still should do that. So I'm going to do a Z-score, though, first for my do. And my Z-score, well, it's going to be what the difference is that I got minus the difference what I should have got. Well, what's the difference that I should have got? Or my HO? It should be 0. So that's going to be the top. And what was the true difference that I did have? Well, you're going to have to subtract these two. Sorry. You're going to have to subtract these two. So you're going to have to go 0.0273 minus 0.04. Yeah, that's ugly. Minus, the whole thing is just ugly. All right, 0.0273. So my first minus my second, what was the true difference that I had? And does that compare with my other difference that I should have gotten? All over my standard deviation. And remember, this is going to be the crazy one where I got to actually do PC. Alright? You're not going off of what I got, and you're not going to put 0 down there. Okay, don't do it. You're going to get undefined if you put 0. And if you put what you got, I'm just going to really get mad at you. So, we're going to put PC, which is 0.0343. Okay, and then its difference, or its opposite. And the opposite of that, I believe, is 0.9657. All over. Well, how many was in the first group? 2051. 2051 was in the first group. Okay? Plus another one, 0.0343 times 0.9657. All over a total of how many were in that second group? 2030. Okay? See, Henry, calculate it out. I'll give you 3 seconds. Okay. Exactly. Well done, Henry. Alright, so my z-score should be negative 2.47, which then, if you look in the back of your table, you should get a p-value. What's that probability? Probability should be 0.0068. Boy, that's a really small probability. If it was true that there was no difference, I had this amount of chance of getting my sample. That is really small, less than 1% chance of getting my sample if the true possibility was 0. I don't think it was probably really 0. I really think that there's probably a difference between the two methods of improving cholesterol level. So, what's my conclusion? Well, I did have a significance level of 0.01, right? My p-value is definitely, well, it's not definitely, it's lower than 1%. So I am going to reject HO. Okay, I'm going to reject HO and I'm going to say, it appears gemfibrozil reduced cholesterol levels. Okay? Because if it was at 0, there was really no difference between the placebo and gemfibrozil. The sample I got, I would have had a 0.6% chance of getting. That's too low. Alright? So that is how you're going to do significant tests. Remember your PC. Okay? Remember your PC. I'm going to let you guys hammer it through on your staked plan and do conclude on the last bit of notes here. Remember, this one is going to be a two-tailed test. So when you get that p-value at the end, down here, when you get your p-value, you're going to want to make sure you multiply it by 2 because it's going to be a two-tailed test. Okay? I'm trying to see if there's anything else that's tricky on that one. I don't think so. Okay. So, have at it. Have fun. I will see you when I see you. Bye.